How's it going, guys? Today I want to go over another lead code question. Today our question is called minimum cost to connect sticks, and this is a question that's currently being asked by Amazon right now.
Pull up on your block and I bleed it. Slide, bone drop some, I can't leave it. Walk out these fold, but just check out these leaning.
Alright guys, today our problem is called minimum cost to connect sticks. Again, it's a question that's being asked by Amazon right now. And our problem description says you have some sticks with positive integer lengths. You can connect any two sticks of lengths x and y into one stick by paying a cost of x plus y. You perform this action until there's one stick remaining. Return the minimum cost of connecting all the given sticks into one stick in this way. Okay, so in case that doesn't make sense, we're given a bunch of sticks and we're asked to basically combine them all into one giant stick by adding two sticks together at a time and paying a cost of whatever x plus y is. And we want to minimize that cost of actually combining them all into one stick. So if we look at example 1 here, if we're given stick lengths of 2, 4, and 3, we'd return 14. And the reason for that is the minimum cost to combine those 3 sticks into one giant stick is by combining the stick with length 2 and the stick with length 3. And we then pay a cost of 5. Right? So 2 plus 3 is 5, so that's our cost for combining those two sticks. And then we'd actually add that stick back into our sticks, right? So now we have a stick of length 4 and a stick of length 5, and we've paid a cost of 5 so far. And now when we combine those two sticks, 4 and 5, we're going to get 9, right? So now there's one stick with length 9, and then we also paid a cost of 4 plus 5 to make that stick of length 9, and we had a previous cost of 5, so 5 plus 9 is going to be 14. Similarly here, we have example 2. If you guys kind of want to reason through this and pause the video and take a second to understand why we get 30, I encourage you to do so. And then the problem just tells us that we have a couple of constraints. The number of sticks that we're given is guaranteed to be between 1 and 10 to the 4th inclusive, and the length of any stick is also guaranteed to be between 1 and 10 to the 4th inclusive. Okay, so now let's think about this problem, right? One thing to notice is that they talk about minimum cost, right? So we want to optimize this. We want to make sure that however we combine all these sticks to get one stick, we want to make sure that the cost is minimized. And so this is kind of an indication that we want a greedy solution. And what I mean by this is if we can actually greedily take the two smallest sticks at any time we're combining two sticks together, if we make sure that that cost between combining those sticks is minimized, and we constantly do that every single time we add two sticks together, we're going to make sure that we actually minimize the cost over the entire problem. And so this is a greedy problem, and therefore we can actually implement a greedy solution. And what I mean by that is we actually can take greedily the two smallest sticks at any given time in our sticks, combine them, and then pay that cost. And if we constantly do that until we have one stick left, we'll guarantee that we minimize the cost of combining all the sticks. So now actually, how do we make sure that we efficiently find the smallest two sticks to combine? Well, a really easy way to do that is we could just have a min heap, right? If we had a min heap, we quickly know the two smallest things to combine, right? We'd take the root of the heap and pull it out, and then it would reheapify, and we'd take the root of the heap again, and now we'd have the two smallest sticks out of all the sticks we have. We can pay the cost or whatever it is to combine them, and then we put that stick that we just created by combining them back into our heap, and we constantly do that while we have sticks to combine. So hopefully that makes sense, and let's start walking through the code. So we're going to have a cost that we need to return, so I'll say int cost, and it's going to start as 0 because we have paid nothing because we've combined no sticks so far. And now we need to actually make that heap so we know what sticks to combine at any given time. So I'm going to say priority queue, and it's going to hold integers, min heap equals new priority queue. Awesome. And now we just need to actually add all our sticks into our heap so that the heap can build nicely for us so we know the two smallest sticks to start with. So I'll say for every stick in sticks, let's say min heap dot add the current stick. Great. And now we said that we need to keep combining sticks until we have one stick, right? So that means that we want to combine sticks while our heap size is greater than 1. So I'll say while min heap dot size is greater than 1, we need to start combining the sticks that we have, right? Or we need to keep combining the sticks that we have available. So now we just need to take the two smallest sticks that we know will be, and we know that will be at the root, right? So we'll take always from the root. And now we need to pay whatever that cost is of their sum, right? So let's make a variable sum, and that's going to be equal to minheap.remove. And so that's actually going to give us the first stick. And we're going to say plus minheap.remove again, and that will give us the second smallest stick. Great. So now once we actually have simulated combining them, right? We're paying the cost to combine them. This is their sum here. Now we need to add to our cost that sum, right? Because that's the cost of actually combining those two sticks, whatever their values are. So we'll say cost plus equals sum. And then finally, once we combine those two sticks, we need to make sure that we put it back into our heap so that we can continuously keep combining any of the sticks we have remaining. So we'll say min heap dot add whatever their sum was. Great. And so once we actually break out of this loop, guys, we will have effectively combined all the sticks into one giant stick. So all we'll actually have to do is return the cost that it took to do so. So now before we submit this, let's just talk about our runtime and space complexity. And our runtime here would be n log n, right? Because we're building up a heap to keep all the minimum sticks in it, or the minimum stick lengths organized. And then we're removing effectively everything from the heap. So that's going to be n log n runtime, because when we remove from the heap, it's going to need to reheapify every time, which will take log n time. Doing that for n items, that will give us a runtime of n log n. And then in terms of the space complexity, we have n elements, right? Which is n is the number of sticks, and we're putting them all into a heap, so we're using O of n memory. So again, our runtime is going to be n log n, and our space complexity will be O of n, where n is the number of sticks that we're given. So now let's submit this and make sure that it works. Awesome, and it does. So guys, that's how to solve minimum cost to connect sticks. Again, it's a question that's being asked by Amazon right now. If you guys enjoyed this video and found it helpful, do me a favor and leave the video a like and subscribe to the channel for more. And I'll see you guys next time.
Pull up on your block and I bleed it. Slide, if I don't drop some, I can't leave it. Walk out me cold, but the tech got him leaning. Never let the beat get cold, it's a mean. Pull up on your block and I bleed it. Slide, if I don't drop some, I can't leave it. Walk out me cold, but the tech got him leaning.